This is part 2 of a series of videos about compilers and the compilation of programs. This video focuses on the tokenization of source code and the role of the symbol table. Lexical analysis is the first stage of compilation. This is done by a component of the compiler known as the lexical analyzer. This is sometimes also referred to as the lexer and sometimes as the scanner. The word lexical relates to the words or vocabulary of a language, and a lexicon is another name for a dictionary. In terms of compilation, the purpose of lexical analysis is to determine the meaning of the individual words within the source code. The input of the lexical analyzer is the source code of a program. As far as the lexical analyzer is concerned, this is just a long string of text. The output of the lexical analyzer is a stream of tokens. So the lexical analysis stage of the compilation process is sometimes referred to as tokenization. Here's a fragment of source code written by a programmer. It's in no particular programming language, although it is very similar to the beginner's all-purpose symbolic instruction code, BASIC. To the lexical analyzer, the source code might look more like this. In addition to white space made by the spacebar, it contains white space in the form of line breaks and tabs. Scanning from left to right, one character at a time, the lexical analyzer's job is to recognize and separate out the individual elements of the input string, breaking it up into the substrings that are the individual words of a program. The substrings that the lexical analyzer is attempting to identify are known as lexemes. A lexeme can be a keyword like if, then or end if. It can be a relational operator like the less than or equal to sign, an assignment operator such as the equal sign or two equal signs in some languages. It might be an identifier such as a variable name or a function name. It could be a numeric constant, a literal string, or even an individual character such as a parenthesis, a comma, or a quotation mark. The lexical analyzer needs to peek ahead, looking for spaces as it scans the input string, so it can determine where one lexeme ends and the next begins. Lexemes can be recognized by the pattern of adjacent characters, which have been defined using regular expressions within the lexical analyzer program. In some programming languages, certain types of white space are also lexemes. New lines and indents, for example, are essential lexemes in layout-sensitive programming languages such as Python and Haskell. In the programming language shown here, which is very similar to Visual Basic, most white space is superfluous and is therefore ignored. White space is effectively discarded. During lexical analysis, any code comments included by the programmer will also be ignored and so effectively discarded. For each lexeme, a token is generated containing the category of the lexeme and the lexeme itself. With some compilers, each token might contain additional information such as its starting position and ending position within the original source code file, useful for reporting errors later. The lexical analyzer has a very limited ability to detect errors within the source code. It might spot a few illegal characters, but it knows nothing about the individual keyword spellings. A misspelt keyword might be recognized as an identifier. The lexical analyzer also has no knowledge of the order in which related keywords are allowed to occur, or mismatched data types, for example. Its main purpose is to break the source code up into individual pieces, so that the way these pieces have been combined can be checked for correctness later. Depending on the way the compiler has been designed, the lexical analyzer might also begin to construct a data structure known as the symbol table. This is also known as the name table. The purpose of the symbol table is to provide the compiler with quick access throughout the entire compilation process to all kinds of information about each symbolic name used within the source code. Symbolic names include identifiers such as variables and constants. But it doesn't stop there. Other names in the symbol table might include arrays, functions, subprocedures, parameters, classes, properties, methods, pretty much anything that's been given a name by the source code programmer. Each name encountered within the source code is quickly looked up in the symbol table to see if it already has an entry. If not, a new entry is made. It's not uncommon for a compiler to use more than one symbol table. Because the same variable may be declared several times in a program with different scopes, a set of hierarchically organised symbol tables, one per scope, is a common way of dealing with this. For the purposes of this discussion, let's assume that there is only one symbol table. The lexical analyzer has no knowledge of the meanings of the tokens. So if a symbol table is created at this early stage, the lexical analyzer may well place an entry inside it for every unique token that it comes across. In some compiler designs, the lexical analyzer will pre-populate the symbol table with all of the programming language's reserved keywords, such as if, then, else, for, next, and the like. Other compiler designs might make use of a strings table alongside the symbol table. So this instead will be pre-populated with the reserved keywords and a unique number to represent each keyword. In addition, any other string encountered by the lexical analyzer within the source code can be put into the strings table along with a number to identify it. Each token and its corresponding entry in the symbol table can then contain a simple pointer to a location in the strings table. With programming languages that place no limit on the length of a string, the use of a strings table can make a token stream and the symbol table much more compact, therefore leading to performance benefits. In this series of videos, we'll continue by considering a compiler that does not employ a strings table and only a single symbol table. To summarise then, lexical analysis is done by the lexer, also known as the scanner. Lexical analysis identifies lexemes within the source code, the words of the program. White space and comments are usually discarded. The lexical analyzer generates a stream of tokens. Each token is passed to the syntax analyzer, otherwise known as the parser, on request. The lexical analyzer creates a symbol table of names used in the source code by the programmer. The lexical analyzer might also create a strings table to keep the token stream and the symbol table as compact as possible. And finally, the lexical analyzer is capable of only very limited error checking. Most of the error checking is done by the syntax analyzer.